think most people avoided this question. It is quite a challenging one for 6 marks. The principles are okay, but 6 marks is difficult, so let's have a look. It's not a describe one. We've really got to explain what happens and why. So we're constantly thinking what and why. All right, gaseous exchange at the alveoli. All right, so not around the body with the muscles. This is specifically at the alveoli and the capillaries around the alveoli. And then the context is exercise, because we're looking at a cyclist competing in a road race. So the first thing we might need to say or think about is that gaseous exchange will be bigger, faster and bigger than compared to rest. You have to think about the sports science context as well as the science. So the sporting context as well as the science, sorry. Let's have a look. All right, so exercise, not rest. If in doubt with these kinds of questions, always try to start with a little introduction. What is gaseous exchange? Maybe highlighting your key term and getting your answer in there. If you're really struggling for this one, we want to think about the idea that at the alveoli, we've got oxygen coming in because we're breathing in oxygen, and we should have carbon dioxide going out because we're breathing that out. What that means is that when we breathe in, we've got lots and lots and lots of oxygen in the alveoli, which creates a high concentration or a high pressure. The fancy way to say that is partial pressure. If we've got a big pressure of a gas in an area, then that's going to create a pressure which will force diffusion, and that means that these molecules are going to actually go through this very semi-permeable membrane of the alveoli wall that's only 1 cell thick. So all of those gases are going to move from the alveoli into the capillaries, or specifically the pulmonary capillaries, which are around the alveoli. The same thing is true of the carbon dioxide. We've got loads of carbon dioxide that's been pumped back from the heart in that double pump. So we've got the heart and the lungs. We send deoxygenated blood back, and then we bring oxygenated blood back to the heart. So all this CO2's got to go into the alveoli to be breathed out. You could draw a picture. There's nothing to stop you at all from drawing a picture to clarify what you mean, and actually it can be quite helpful. So have a quick read, but this bit here is the description of the picture. We need to say that this happens at a faster rate during exercise because it is sport science. You might want to say why, greater demand. And then this is the sciencey bit down here. This is the harder bit in a way, but gases move from high concentrations to low concentrations. If there's a big pressure because there's high concentration, then that's going to push or diffuse that substance across the membrane, And in this case, we could use the example of oxygen. Oxygen goes from the alveoli into the bloodstream. Have a pause, have a read. There you go.